Let's look at the solution of algebra bites. What is the number of common roots of the two equations given below? Here, these two equations. If they have common roots, first let's identify what are the common points where they intersect. Wherever they intersect, the value of the function would be equal. So this is equated with this. We end up getting 4x square plus 5x plus 1 is equal to 0, or 4x square plus 4x plus x plus 1 is equal to 0. 4x taken out common, x plus 1 plus x plus 1 is equal to 0, or 4x plus 1 or and x plus 1 is equal to 0, which gives me two potential values of x. X could be equal to minus 1 by 4 or minus 1. But these are the points, these are the values of x for which these two functions return the same value. So for us to know whether they are common roots or not, we have to plug in these values into either of these equations and then check if we are getting 0 as the final value. So when I plug in x equal to minus 1 by 4, I get minus 1 by 64, then minus 3x squared, so minus 3 by 16, then minus 1 by 2 plus 5. So minus 1, minus 12, minus 32 plus 5 into 64 or 320. I know this is definitely not equal to 0. So this is not a common root. This is a point where the two functions intersect, but that is not a common root. Okay. Now let's plug in minus 1. We'll get minus 1, minus 3, minus 2 plus 5. This is also not equal to 0. So this is also not a common root. So how many common roots do these two equations have? They have 0 common roots. They have 2 points where they intersect, but they do not have any common roots. Okay. Next, let 1 plus x square raised to the power n be equal to a0 plus a1 plus blah 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 blah, where n is natural. Wonderful. And then we have been given this expression. Then the value of n is. Now see, I can of course give you the solution, but the way that solution should come to your head is, I have to somehow manage to reach a situation wherein I am only left with these terms. So this term is cancelled and a3x raised to the power 3 is cancelled and a5x raised to the power 5 is cancelled. Basically, all odd powers of x have to cancel out. So how you can work that in your brain is, let us put x equal to 1. If x was equal to 1, can you see LHS will turn to 3 raised to the power n is equal to a0 plus a1 plus a2 plus a3 plus a4 blah 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 blah. It will go on till a to the and base would be 2n. This we have got. Now I want this a1 term gone, this a3 term gone, odd powers of x gone. Best way would be, let's put x equal to minus 1, which in this case LHS would now be equal to 1 raised to the power n is equal to a0 minus a1 plus a2 minus a3 plus a4 blah 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 plus a to the base 2n and everything. So wonderfully well, now what we have is 3 raised to the power n plus 1. I'm adding both these equations. A1 gone, A3 gone. Whatever we are left with is 2 times of A0 plus A2 plus A4 plus A6 blah 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 up until a to the base 2n. Best thing in the world is the fact that we already have the value of this. So 3 raised to the power n plus 1 is equal to 730, or 3 raised to the power n is equal to 729, or n is equal to 6, which is what we needed. What is the value of n? and new value of n is 6. Next question. Three friends, Amrit, Bilal, and Chandan, are playing a game, namely Marble Phenko. Each of them has a certain number of marble balls. The total number of marble balls with all the three friends is 100. 6 times the number of marble balls with Amrit is 384, more than the sum of the number of balls with Chandan, and 2 times the number of balls with Bilal. The number of marble balls with Bilal cannot be less than. Okay, so one thing that you should infer from this question is you will not get a precise answer. You will get a limit. There is an extrema that you have to check. Okay, I'm saying let Amrit have X balls, let Bilal have Y balls, and by extension, Chandan will have 100 minus X minus Y balls. Equation wise, what is told to us is the total number of marble balls with all the three friends is 100. That you have taken care of. 6 times the number of marble balls with Amrit. So 6x is 384 more than the sum of. So this minus 384 should be equal to sum of the number of balls with Chandan, 100 minus X minus Y, and 2 times the number of balls with Bilal, plus 2y. This is what we have got. Okay, so now X comes here. I get 7x minus y gone plus y gone. So we are left with minus y is equal to 484. Now, although they have not explicitly stated it, but understanding wise, of course, the number of balls with somebody has to be a whole number. It cannot be a negative number. So 7x minus y, for y to be as small as possible, the number of marble balls with Bilal cannot be less than, we have to identify the smallest possible value of y. This number here, 7x minus y is 484. Can you find a multiple of 7 greater than 484? Of course, the next multiple that you would see is 490. So at x equal to 70, y will turn out to be 6. 490 minus 6 gives me this. X is 70, y is 6, c will turn out to be 24. Just in order to be extra sure, let's see, 6 into 70 is 420, minus 12 gives me 408, minus 24 does indeed give me 384. So everything perfectly fills out. The number of marble balls with Bilal cannot be less than, happily, 6. It cannot be less than 6. It is not to say that x and y can only take values of 70 and 6. The next possible value would be 71 and 13. This would also be acceptable. This increases by 1, this increases by 7. Yes, this would also be acceptable. Let's go ahead and, for the sake of time pass, let's check 71 and 13. So 16 here. 71 into 6 is 426. Minus 26 is 400. Minus 16 is indeed 384. So all conditions will also get satisfied at 71 and 13. But we are looking for the smallest possible value of y, smallest possible number of balls that Bilal has to have, and the answer to that would be 6. Next, Mrs. Gupta is a teacher at Navodaya school. She needs to indent for chalk sticks to last the entire academic year, comprising 175 working days. When a chalk stick reduces to 1/6 of its original length, it gets too small to be used. Hence, she keeps it aside. Later, she joins 6 such pieces and makes a new chalk stick and uses it. If she uses 5/6 of a chalk stick per day, what is the minimum number of chalk sticks she should indent for? Okay, let's see. Number of chalk sticks that she finally gets to use. Number of chalk sticks that Mrs. Gupta finally gets to use. Let it be as in, if she indents for n, not only will she use n, she will also use n/6 of them. N/6 of them. Let's say she indented for 24 chalk sticks. She uses them for 24 days and also 24/6, 4 more days. With 24 chalk sticks, she ends up using it for 28 days in total. So n/6. But this is not the only thing. Let's say she indented for 42 chalk sticks. So 42 days she would be able to use it. Next, 42 by 6, she would be able to use it for 7 extra days. But 7 is not the end of it. She would also be able to use it for one more day. Of those 7 new chalksticks that have been identified, or created, 1/6 of them would also be left, and they can also be used to create more chalksticks. So total number of chalksticks that she ends up using if she indents her n is n plus n by 6 plus n by 36. Simply see your the integral value of n by 36. Can you see for 42 it would be 42 plus 42 by 7, sorry, by 6 plus 42 by 36 plus n by 216, so on and so forth. This has to go on, and this has to be overall greater than equal to 175 because she needs a supply for 175 days. If I take out n common, what is left in the bracket is an infinite GP with a common ratio of 1 by 6. This has to be greater than equal to 175. Okay. So n into this would be equal to how much? 1 by 1 minus 1 by 6, or is greater than equal to 175, or n into 6 by 5 has to be greater than equal to 175, or n has to be greater than equal to 175 into 5 divided by 6, or n has to be greater than 875 by 6, or n has to be greater than 840. May 140 gone, we are left with 35. So 145.833, n has to be greater than equal to 145.833. But of course, chalksticks cannot be ordered in parts. The answer to the question would be the next integral number, which is 146. If she ordered for 146 chalksticks, it will last her for the entire year. Next question. Let P be a solution of the equation x raised power 6 minus 2 is equal to 0. Okay. The value of P minus 1 blah 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 is. Okay. I'm working with this alone. Can I go P minus 1 into, I take out P raised to the power 12 outside, left with 1 plus P square, so on and so forth. It will keep on going up until P raised power 29. There is a geometric progression. Wonderful. P minus 1 into P raised to the power 12, 1 into P raised to the power 30 minus 1, whole thing divided by P minus 1. So this P minus 1 and this P minus 1 is 1. Finally, what we need is P raised to the power 12 into P raised to the power 30 minus 1. Okay. Now, what do we know about P? P is a solution of this equation, which means if I replace x with P, I will get 0. So P raised to the power 6 minus 2 is equal to 0, or P raised to the power 6 is equal to 0, which is wonderful because I can rewrite these terms as P raised to the power 6 square into P raised to the power 6 raised to the power 5 minus 1. So this is 2 square 4. This is 32 minus 1. Or finally, what we need is 4 into 31. The correct answer would be 300 so sorry, not 300, 124. The answer would be 124. That will be all for this episode. Hopefully you learned something.